So once again here we're looking at vertical motion. We're going to start off with our sketch. As we know that it's thrown vertically upwards from the point O, so point O normally refers to the origin, so that's going to be our starting point here with a velocity of 30 meters per second. We know it's thrown vertically upwards, so we also know that gravity is going to be important, so acting downwards with an acceleration of 9.8 meters per second squared. And we're asked to find the total time for which the ball is 20 meters above its point of projection. So we can draw a nice dotted line there and represent that relative to the base with a distance of 20 meters. So that's the distance we're going to be looking for in our CVAT equations. I'm going to pick my positive direction to be upwards. And I'm just going to mark on the path that I'm expecting the ball to take as it comes back down to the ground level after decelerating due to gravity. So, filling in our data table, we're asked to find the total time for which it is 20 meters above its point of projection. So, looking at the diagram, we can see that the ball is going to be exactly 20 meters above its projection points at 2 points, here and here. So if we can calculate the two possible times where it's there, we can therefore look for the total time in between those two where it is following this path here. So we're looking for a displacement of 20 meters, and it's 20 meters up from the original point, so positive 20 meters. Initial velocity 30 meters per second. Final velocity at the point at which it's at 20 meters, we have no idea. We're not sure what speed it's going at that stage. Acceleration is due to gravity, minus 9.8 meters per second squared. And the time is what we are looking to calculate. So SU and A is our data, T is what we're trying to find, so we're going to be using S equals UT plus a half AT squared. Subbing in, 20 equals 30t plus a half minus 9.8 t squared. Okay, again I can spot that t squared term. I'm looking at a quadratic, so I'm going to rearrange and make it equal to 0. So 4.9 t squared minus 30t plus 20 equals 0. And I'm expecting to use my quadratic formula. Hopefully you are starting to remember this formula now. Okay, so we're going to sub in our values. T equals 30 plus or minus the square root of 30 squared minus 4 times 4.9 times 20. And all of that is going to be divided by 9.8. So one of our solutions is going to be 5.36 seconds, and our alternative solution is 0.76 seconds. We're asked to find the total time for which it's above 20 meters, so the total time is going to be equal to the difference between these two, 5.36 minus 0.76, which is equal to 4.60 seconds. And there we are.